Alright, so yesterday, or the past 2 days, we have multiplied and divided rational expressions, fractions, whatever you want to call them. So now we will add and subtract. Okay? Everything that we do as far as adding and subtracting, the reason why we do multiplication and division first is because it really doesn't matter what our denominator is. But whenever we have adding and subtracting of fractions, we have to have like denominators or common denominators. Okay? I will tell you that, to be perfectly honest with you, adding and subtracting, whenever you have like denominators, that is not going to be any sort of issue. It's going to be whenever we have unlike denominators. Okay, so like if I have, but it's still the same setup, just like it would have been if you would have dealt with regular fractions. Like on number 1, where it's 3/7 plus 2/3, what do you need to do before you can add or subtract? I can't just go 3 plus 2 and have 5, and 7 plus 3 and have 10, and call it 5/10 and then reduce it to 1/2. Okay, I have to have a common denominator. So that means that basically, can I multiply the 7, essentially? Okay, or really, I would always look towards the smaller number, okay, the smaller denominator. Can I multiply the 3 by anything, an even, nice, neat number, to make it into a 7? No. Okay? So I always want to look at the smaller denominator first, look to see, hey, can I get that to look like the other one? I can't do it in this case. Okay? So that means I'm going to have to multiply both fractions. What do I have to multiply the first fraction by to where the denominators will match? And what do I have to multiply the second fraction by so the denominator will match? Or what's an easy way of doing it? So 3 and 3 here. 7 and 7 there. So then essentially what I have is 9 over 21 plus 14 over 21. Now I can add. So 9 plus 14 is 23 over 21. If I can simplify it, simplify it. If I can't, just leave it as is. Okay, so 23 over 21. Now, it's not always the case that I will have to multiply both fractions. Okay, again, looking at the smaller denominator, looking at the 5, can I turn the 5 into a 10? Yeah, how? Multiplying it by 2. So in some cases, you may not have to touch one of the fractions or one of the rationals, so 2 and 2. So if I have 7 over 10 plus 16 over 10, denominator stays the same. 7 plus 16 is 23, and I'm going to leave it as 23 over 10. Even on one like 3, it works the same way. Nothing's going to change. I can turn the 4 into a 28 by multiplying the top and the bottom by 7. So if I have 3 over 28 minus 7 over 28, denominator stays the same. What's 3 minus 7? Negative 4. Now, can this one reduce? Yeah. So this one can reduce, so I can reduce it as I can divide everything by 4 and have negative 1 over 7, or put the negative out in front. Okay, you can leave the negative on top, you can put it in front, you can put it on the bottom, it really doesn't matter. As long as you only have one negative here, you're going to be just fine.